Okay, let's see. All right, new video. Hello? Okay. All right, good. Got at least one. All right. Again, so we're taking a look at this first derivative test, rectilinear motion. This is for all those people out there in YouTube world named Patar that can't make it to class. So insert page after current. So position S is equal to what? T cubed.
Minus 9t squared.
Something t squared?
9t squared.
9t squared
Plus 15t.
Plus 3.
plus 30. Okay, very good. So my first derivative I would call the what? Velocity. So I could just say it's going to be v of t, or I would say s prime of t. It's both ways I could actually, notate it. So it'd be notated as s prime of t, or it is v of t. But either way, it's going to be 3t squared minus 18t plus 15. Jess?
Yeah.
Okay, good. All right, so we want to know where that's positive, so I need to know where the slope is positive. So first I need to find is my critical points. Critical point is my derivative equal to 0. 0 equals 3t squared minus 18t plus 15. Factor out a 3 to make it a little bit easier. T squared minus 6t plus 5 equals 0. And then that factors pretty nicely to be 1 and 5, right? So t minus 1, t minus 5 equals 0, right? And here's my two different t's, so t equals and t equals 4. So on my number line,
5?
Where would you get 4?
I don't know.
Yeah.
See, I'm seeing who's still awake. Thank you. Thank you. Who's the first person that said 5? Yeah, see? Good job. Someone's awake here. Because I'm not. All right, so 1 and 5. There we go. One and 5. Okay, so what do we do from here? Plug in numbers, right? In between my intervals. So start with 0. So if we start with 0, okay, like I said, I'm going to plug in right here in the factored form, okay, because the 3 is really not going to matter. Okay, the 3 is, if it's positive or negative, it's not going to matter. It's going to just make it 3 times bigger. But in the factored form, it actually works out really well because when I plug it in here, it's easy to see positive and negatives. So let's see again. So we're plugging in 0. So that'd be a negative 1. And that would be a negative 5. So 2 negatives make a? There we go. Now we're plugging in, let's go 2. 2. Plug in 2 right here. On this one right there, we get a positive, but 2 right here, we still get a negative. So a negative and positive makes a negative. All right, to the right side of 5 is going to be 6. So 6 over here, right here, is going to be positive. 6 here is also positive. So positive, positive makes a positive. So where is it increasing? Not negative infinity. Okay, remember, this is rectilinear motion. So where is it starting at? 0. It starts at 0. It's where t is going to be greater than equal to 0. So it's increasing over the interval from 0 to 1, right?
Yeah.
Okay, so, and union. Okay, I will point this out. Watru actually pointed this out yesterday where I made a mistake. We do include the 0 part. We do include. Okay, good job. Thank you. I had to go back and double check my notes. Yeah.
Wait.
So we are including the 0 in the increasing, decreasing.
Yeah, but for the 1.
For the 1?
Shouldn't that be parentheses because the slope is 0 at 1? So it's not increasing or decreasing?
Yeah, I know. That's what I was saying from yesterday. yesterday when I mentioned it, because if you think about it, 0 is not neither increasing or decreasing. But in the book, it actually went and there was a contradiction. So I was looking through it, and he noticed that. So we are to include the 0. Okay, so yes. So this right here, where does it pick up? It picks up at 5, and it goes to, where does it go to? Infinity. That one goes to positive infinity there. See, now that you guys got me second guessing and third guessing myself, because yesterday I was wrong on that. Now I'm gonna be mad if I'm wrong again, like there's a double negative or a contradiction. I have to go back and look at my notes now. They don't actually have it written in interval notation. Nope. Okay, so yes, I was right yesterday. So the contradiction, I don't know, that was weird. The contradiction, or watch who actually found that one. But yeah, my notes actually match what I had yesterday. So maybe it was just those one problems were wrong. Yeah, because I found it right here. So the interval time should be in parentheses, because we're not including the ends. So yes. So looking through my notes, it is supposed to be, yeah, parentheses 0 to 1, and then again at 5 to infinity. I know that was, okay, so.
That was if you brought this program.
Yeah, I'll look at that again to double check, because I really think there's a problem there. Okay, so yeah, we're not including those. So anyway, so it means that the distance is increasing from 0 to 1. Okay, and then in between 1 and 5, it's coming back, isn't it? It's coming back, and then at 5, it goes away again. Okay, so it's like, hey, I'm going to go to Douche Bros. So I'm walking from here to there. Oh, crap, I forgot my money, but my money's in my truck. My truck's parked out there. So I was walking, but I come back to go to my truck. Okay, I got it in my truck. Now I got my money. Now I turn around again and head back over to Douche Bros.
But you can't do they don't do the walk up, so you have to take care of that.
No, I identify as a car. Okay? Listen, they have to accommodate me if I identify as a car. Anyway. Wow, that is like so. I think I just triggered the whole internet right now. Wow. Okay, I almost triggered myself. Okay, so let's see. Determine the intervals where the distance is decreasing. So my decreasing distance, we said, is from 1 to 5. Okay, from 1 to 5. Okay, so C. When does the object reverse direction? At 1 and at 5. Okay, at 1 and 5. Because I'm actually going, then I turn around, come back, right? Then I turn around again. So I'm reversing direction. Okay, does that sound good? Okay, good. All right, so draw a figure to illustrate the motion of the object. Okay, so now, here's me. Oh, crap. Oh, let's see. Dang it, wrong one. No, this first. Okay, and insert page the current. Okay, so here's me. Okay, look at that guy. So I start walking. I'm like, And right here, t equals 1. And at that time, what did I decide? Go back to my truck, right? So, here's my truck. Okay, all right, so. Okay, big monster tire trucks on my truck. So there's my truck, so I go back. So right here, I'm like, oh, I'm heading back this way. Go to my truck, okay? And at that time, we know that t equals 5. All right. Okay, so now that I got my money out of my truck, now I'm like, oh, hey, I'm heading back to Douche Bros. Douche Bros. I don't know, what's the symbol for it? Is it like a big square or something?
Yeah.
It's a what?
Windmill.
A windmill? Okay, so anyway, I'm getting my coffee there. Okay, all right. There's a diagram with a story to go along with it. So hopefully the story is funny enough for you guys to remember. So you will forever remember my trip to Douche Bros. All right, when is the velocity of the object increasing and decreasing?
0 to 1, and then it's decreasing from 1 to 5, and then it's increasing from 5 to a lot of numbers.
Velocity is increasing though. So are we asking for the slope of the slope?
Acceleration.
Double prime.
Thank you, there we go. So yes, we are looking for velocity. So we're increasing and decreasing. So now we're looking for velocity. We're looking for the slope of the velocity this time. So it is going to be a double prime. So I'm finding the slope of the slope. Okay, so when is velocity increasing and decreasing? So I'm going to take my derivative, which was, don't let me forget, it's that 3 thing right there, okay? So you guys are going to help me on that one. God dang it. Insert page. Okay, so it is, so my velocity v of t was 3t squared, right? Plus what?
Minus 18.
Minus 18.
Yeah. Yeah.
18,
TT. Plus production T.
like that, right?
Yes.
Okay, good. All right, so that's my velocity, or my s prime. So now we're going to double prime this one. So it's going to be, it's either v prime of t. It's either that, or it's going to be s double prime of t. But it's also a of t, which is going to give me 6t minus 18, right? 6t minus 18 is going to be my this. So 0 is equal to 6t minus 18. Subtract or factor out of 6. T minus 3. So t equals 3. So that's the change right there, right? So at 3, it's changing. It's changing. So now, if I think about it, for this, I'm going to plug in numbers on the right and left. Okay, but, so let's do this. But don't go too far away from the 3. Okay, so let's plug in. I'm not going to plug in 1, because 1 was my critical number for my slope, right? So I'm going to plug in 2. Okay, so plug in 2 to my derivative, which is going to be right here. So if I plug in 2, what do I get? Negative. So it's negative right there. And, okay, to the right side would be 4. Again, that's less than the 5. That's the critical number from my slope. So it's going to be 4. Plug in 4, and I'm going to get a positive, right? Okay, so now when is this changing? So it's going to be when my acceleration, so my slope of my derivative, is going to be positive from 3 on, isn't it? Okay, so that means that I'm on my way back to get my wallet, right? So I'm running back to my truck. So I'm increasing speed. Okay, my accelerating. All right. Okay, draw a figure that illustrates the velocity of the object. So now for the velocity of the object, increasing and decreasing. So at 3 is right about here, right? Okay. So if that's where it's changing, so it's decreasing, that means that over the interval from here to here, I slow down, right? I'm accelerating, even though I'm going positive right there, right? I'm going positive right here. My acceleration is slowing down. Okay, my acceleration goes to 0 here. Okay, it's a negative acceleration, so that means I started off going fast. Let's see. So if I plug in 0 for my velocity, I start off going 15, right? You know, what's the units on this one anyway? Just distance and time, right? There's no real units. So it's usually meters per second, but still. So it would be 15 would be my starting, right? So given my diagram, and I have it in blue now, I start out at 15, and from 0 to 3, I'm slowing down that whole time. But now the change is right here. At 3, I'm like, crap, t equals 3. So I look at my watch, I'm like, dang, you know what? I only got a couple more minutes before school starts. So I, at 3, decide to pick up the pace. So I start running. So I start accelerating from 3 all the way to douche bros. That's what that means. My acceleration is positive, so I'm picking up speed. So even though I'm coming back towards my truck, this is the point where I start running, and I get to my truck, and then head over to douche bros. So all this is going to be positive from here. This way is all positive, where this one is all negative. Does that make sense? Hopefully the diagram and the neat story that goes along with it will help. You guys will always remember that one. Okay, and hold on. I think this is what example is this? Because I don't want to go too far into this yet. Yes, we're doing a concavity. All right, so now concavity. Concavity of a function. Okay, this right here, concave up. Now, this is what I want you guys to do. Everyone, right now. Yes, this is one of those weird thingies that I had you guys do with your hands. Now, so, with your hand, show me concave up. Okay, this is a concave up, isn't it? What does it tell you about this down here? It's a minimum, right? So if that's a minimum, this is going to be a concave up. So at a minimum, concave up is going to be positive. Okay? So the concavity is positive here. It's opening up, isn't it?
Yes.
Okay, so now, flip your hand upside down. Your hand upside down now. So, this point right here is going to be a maximum, isn't it? This is a maximum. This is concave down. So this is a negative. It just sounds weird until you use your hands on this. Okay? You see how this could be opening up. It's a positive, even though I have a minimum here. Okay? Going down, that's a maximum, and I have a negative here. All right, so We got to throw up some gang signs at Patar when he finally shows up for this one. All right, okay. So let a function be continuous on a closed interval from a to b and differentiable on the open interval from a to b if f is concave up, graph of each of its tangent lines through there, concave down. Okay, so now, where's the point that I'm looking for? Be a function, suppose exists. Okay, so this is what I was talking about right now. So a function is continuous on closed interval. Suppose that f double prime exists on open interval. F double prime is greater than 0. Okay? F double prime is greater than 0. Then it is concave up. Okay? Bam. Concave up. So this means that it is a, so f prime would be a min. Okay? But this is an oversimplification. I'm just using this as an example because not all concavities are at my critical points. It's possible to have a concavity that's not going to be a min or max. Remember how we get those weird functions that are like an S? Okay? That one also has a concavity, but it changes concavity there too. So, this is just a simplification so we can use the hand signs so you can see what it should look like. So, f double prime is less than 0. Interval, it's concave down. So, f would be a max. Note, when f prime and f double prime both exist on an open interval, the function f is called twice differentiable. So that means we could take the first and second derivative. Show that this is concave up on its domain. Okay, so f prime of x is e to the x. F double prime of x is e to the x. So, what did I say? Set it equal to?
0.
Okay, set it equals 0. Okay, 0 equals e to the x. ln. Okay, so now certain things that we have to know about this. How am I going to get 0? Can I get 0? You can't get it. Why can't I get it?
Because f to the up should be bigger than 0.
Okay, yeah. So if I look at a graph of e to the x, okay, there is an asymptote out there, right? So it's never really equal to that. I get an asymptote right there. So I can't get this. It's going to be undefined. But what I can do is, okay, over my interval, what can I do? Can I plug in? Okay, so if I plug in a number there, let's say plug in the number 1. Plug in the number 1, what do I get?
3 point.
Yeah, I get a positive number, don't I? Okay, so if I have, okay, f double prime of 1 is going to give me e to the first, which is 2.7 blah, 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 right? I don't know, what is e to the first? It's 2.7 something.
2.71828.
Yeah, okay. So it's a positive number, isn't it?
Yes.
Okay, so what do we say about the positive number? So,
It's increasing.
okay, okay, think about it. Positive number, what did I say about the positive number?
Concave down.
Okay, so let's look. Okay, we're saying that this is going to end up being, if it's positive, okay, if f double prime greater than 0, okay, it should be less than 0. Okay, let's take a look at my graph so we can see this at 1. So I don't screw this one up. E to the x. There we go. Okay? So, does this match? If it's positive, right, goes up. So there should be some type of minimum, right? So that's why you think of it like this. It's going down here would be like a minimum. So therefore, all this over its interval is all going to be concave up. All of it's going to be concave up. So there is no inflection points. Okay, that's the key word for this one. Inflection point. It's not going to change concavity anywhere on here. Now, does that make sense or no? Did I just confuse the crap out of everyone?
It makes sense.
Friday? You're shaking your head at me. Yeah, SMH, right? No? Okay. Okay, let's see. So we said that this is going to be concave up over the entire interval. Okay, I like this one. This is a good one. Because the other one is all theoretical. Hey now. That was all the stuff that I mentioned yesterday.
Okay, yeah, they should have came out and.
I know. Okay, so let's go ahead and find my, yeah, thank you. Okay, so find the derivative. So f prime of x is 3x squared minus 12x plus 9. So there's my first derivative. Second derivative, f double prime of x is equal to 6x minus 12. Yes? Okay, so now, go ahead, set it equal to 0, and I get x is equal to 2. X equals 2. So, that's going to be an inflection point there. That's going to be my change in concavity. Okay? Now, let's do the first derivative also. And that first derivative is going to help this out. So if I set the first derivative equal 0, okay, first derivative equals 0, so it's going to be, let me see, 0 equals, what do I got to get? 3 quantity x squared minus 4x plus 3, and then I should get x minus 1, x minus 3 equals 0. So x equals 1 and x equals 3. All right, so I have the first derivative critical points, and I have the concavity, which is going to change my point of inflection. So at 2, okay, at 2. So now I have a bunch of stuff right here. So I'm going to insert a new page. Number line. What was it? 1 and what? 1 and 3, and at 2 is my change in concavity, right? All right, let's start off with.
All right, sir.
All right, thank you, thank you.
Yep.
Okay, we're going to start off with. Let's go a 1. Let's do a 1 into my second derivative. A 1 into my second derivative is going to give me negative. So I know it's a negative. So if that's a negative, what do we say about the negative? Do the hands. Right there. So that means that at 1 it has to be a max. This should be a max. Okay. What about 3? Okay. Let's do 3. What do we get? It's positive, right? Oh, dang, right there. That's going to be a minimum, right? So I'm going to do it like this. So I'm going to put a dot right there. Okay? So just doing concavity, let's say it looks like this. So, like that. Something like that. So 2 is a point of inflection. That means it's changing from a concave down to a concave up. So if you're going to use both hand signs, you got to throw up both gang signs at the same time. Bam! There it is. Oh, look. Oh, I flipped it over. Okay? That's where your fingers go together. That's where your fingers go together in between your two concavities. That is your point of inflection. So, let's take a look. Let's test this out to see if this is going to be a min or a max. Okay? So, what did we say? So, the first derivative I have right here. So, if we plug it in, I know it's got to be, certain things got to happen, right? So plug in 2, because we're going to check to see if it's increasing or decreasing, right? So 2, if I plug in 2 to my first derivative, that's going to give me a positive and a negative, so it's a negative. So this is a negative slope, right? This is a negative slope. Now let's plug in the number 0. 0, so it's a negative and negative, which makes a positive, doesn't it? Okay, so that means that the right side over here is a positive. So what did we say? If it's changing from a positive to a negative, that has to be a max. Very good. If it's going to positive and then negative, that's a max. Hey, we already showed that with our concavity there. Now let's do the same thing on the other side of 3. So let's say 4. So I plug in 4, I get a positive, and I get a positive, so 2 positives make a positive. So I know that all this right here is plus. So if it's going from negative to a positive, that is a minimum. You guys feel good about this now?
Yes.
Okay. That's why I like these problems right here, because it's, you can, a lot of gang signs for this. Okay, so I'm going to stop right there. Don't forget, like, share, and subscribe. Next week, I would like to redo that test. Remember that test for Unit 3?
Yeah, we all failed.
Okay. Not everyone failed. It's just the scores weren't like what I like. Okay. So, like, share, and subscribe. Hit that notification button and make sure you purchase some of the store merchandise from the link below. Okay. Get that nice swag.